Hello everyone and welcome to PISA Presents. Today we're going to be looking at some fossil corals of the world. So let's begin. First of all, corals are marine, that is, sea living animals. They're in the phylum Cnidaria, the class Anthozoa. A single coral is called a polyp. Now that polyp takes calcium carbonate from seawater to make bodily structures, hard structures, of either the minerals aragonite or calcite. But still, all the same, corals in general can be either soft or hard bodied. Contrary to myth, they're not all completely hard bodied organisms. So this is just going to be a really quick peek into geologic time because some of these terms will become important later. So time is divided mainly into eons, eras, periods, and other subdivisions as well. Now, keep in mind that because the continents are always moving over time, any particular site has not always been in the same place or even had the same climate from one time to the next. So, as an example of this, during the Ordovician period, Pennsylvania was partially covered with water, so it was time for lots of corals. Now, the oldest known corals are from the Cambrian, that's over 500 million years ago. Because they were already pretty much full force by then, we know that their ancestors had to have evolved from a bit earlier because obviously they didn't just spring into being. Now, instead of going into the mess that is the absolute disaster dumpster fire between arguing over the evolutionary origins of corals, please just look at this cute little baby chick instead. So, yeah, we're not completely sure how they evolved, and there's a lot of arguing there that I do not have the time or desire to unpack, so let's continue. So, corals first appeared about 510 to 535 million years ago. Later in the Ordovician, we see the origins of two major groups of fossil corals. One is the rugose, or horn corals, because they look like horns. They were fairly dominant in the Silurian with both solitary and colonial forms. Solitary is just kind of one chilling by itself, and colonial is a term referring to corals that take, a group, like a colony. Now, the group called tabulate corals also came about in the Ordovician. An end period extinction event did reduce their numbers some, but they were still around, and however, their numbers declined again during the middle of the Silurian. Sadly, both rugose and tabulate corals went extinct in the giant Permo-Triassic extinction event. Now, this is Halicites, a tabulate coral from the Silurian of Ohio. It's, oh my gosh, that is just beautiful. So the Triassic gave rise to the Sclerotina, who are also known as hard or stony corals. They are still alive, so they're still with us. Now, arising in the Ordovician was a group of species that all had eightfold symmetry. They include a group which today are also called soft corals. So yes, some of these species that we have around today do have their origins in fossilized forms. Now, you may see a term that says agatized fossil coral. Now, these actually are not all fossil corals. So now, calcite. As it precipitates very easily while they're alive, calcite is a primary component of coral skeletons. And because it's so gosh darn common, it's a ready mineral to replace other tissues during fossilization. So agatized corals are formed when silica, which is typically from groundwater, gets involved in fossilization. This silica can take the form of traditional quartz, chalcedony, or really any kind. So yes, fossil corals aren't stone. But for a long time, and even, I hate to say it, still today, because, the internet is weird, people debated what corals even were at all. Animal, plant, something else, and then what kind. Now, this guy right here, Herschel, was one of the folks that really started to question that back in the day, just thinking, well, what is a coral exactly? Now, that right there is a living coral outcrop or Flynn Reef, which is the Great Barrier Reef in Australia. So, how are there fossil coral reefs? That image may kind of bring the question to your mind. Why, yes, Virginia, there indeed are. Now, but I cannot talk today. Not all reefs are made of coral, so not all substances can easily survive fossilization. Fossilization is a very difficult process to survive. That's just kind of how it is. I mean, it's very hard on the fossil itself. And because Earth's land masses don't stay in one place, that's a lot of grinding and knocking around these things. So many of these large coral reefs that are fossilized are in Britain, and they tend to be in the form of atolls, barrier reefs, or fringing reefs. But the famous El Capitan is actually a barrier reef made of algae and microbes. So there we are, right there. That is absolutely beautiful. Coral or not, ancient fossil reefs are still subject to erosion and weathering, further altering how they look apart from, air quote, modern reefs. Now, Fossil Guy is a wonderful, wonderful site. I always highly recommend it to people. So just look it up. They have a lot of regionalized, specialized pages and a lot of look-sees into various coral species in the tri-state area. Now, agatized fossil coral has been Florida's state stone since 1979. Yes, it's not a stone, but go Florida for picking that. So the Tampa Bay region was once well known for its corals, but all the development in the area has greatly since limited the supply, sadly. Now, this is absolutely beautiful, Coanites. Falls of Ohio is a state park and a national natural landmark with a lot of coral in it. Favosites is a very famous coral. It's also called a honeycomb coral. It's a colonial one. The individual tubes right there are called corallites, and they are divided by individual plates called tabuli. Now, looking at a modern coral under a microscope, you can see that it's made up of scores of teeny, teeny, tiny ridges. They kind of sort of look like the growth rings on trees, with some corals gaining a new ridge daily. However, a couple of Devonian corals grew 400 ridges yearly. Why? So, why all of a sudden did you grow like so many ridges and then today you don't really as much? Well, those additional ridges are markers of the changing nature of the Earth. Because you see, not only have the continents been moving over time, the very rotation and the movement of our planet is not consistent over time, and it's even slowed since the Devonian. There are about 35 to 40 fewer days per year today than it was in those times, and all these extra ridges are a reflection of just really the Earth and the continents and other things changing their shape and position throughout time. Now this is another lovely species right here, Heliophyllum. Heterophrenitis has a wonderful series of images right there. That is another horn coral. The cup itself, the main area of it, is called a calyx. The individual grooves within them are known as septa. Now this is Lophophilidum. Some of these old illustrations are actually pretty good. When you find a source, please don't poo-poo it if it's older. Yes, a lot of mistakes have been made over time, but still, some of the key information there may be very useful and it may be very good to help you. Now, Petoskey stones. We're going to have an individual video later on just these. But still, for purposes of today, they are the remains of a rugose coral. Very, very famous from Michigan, and they were about Devonian age, so say, give or take, 350 million years ago. Now this is Pleurodictum, Stereostylus, and Sophrentis, another very, very famous coral that you can find generally within this area. So now this is just a sample of some of our other videos available on the channel. Thank you very much for watching, and enjoy this look into the wonderful world of fossil corals. Thank you then. Bye.